In this video, I'm going to talk through the worked out solutions to the Unit 2C review worksheet, or 2C5 worksheet. Unit 2C was on point-slope form, so we're talking about linear functions in point-slope form. At the top of my paper, I'm going to go ahead and write what point-slope form is. So point-slope form is y minus y1 equal to the slope times x minus x1. Where I know that m is my slope, x1 and y1 are the coordinates of a point that's on the line. We also had slope-intercept form, so slope-intercept form, and that was y equals mx plus b, where m is our slope and 0 comma b is the y-intercept. So those are the two forms of linear functions or linear equations that we've learned so far. So let's take a look at this. Now number 1 says we have this equation and I want to identify the slope and a point on the line. So because this is in point-slope form, I can identify a point and the slope from the line. I know that the slope is my m, so that's what's right in front of that x. So the slope is just 4. It's not 4x, it's just 4. A point on the line, well, I get the coordinates of the point are x1 and y1. Realize that it's y minus y1 and x minus x1. So here when I see y plus 3, this is really y minus a negative 3. So the y coordinate will be negative 3 and the x coordinate will be positive 5. So it's opposite the sign that you see in the equation. For number 2, it says write an equation in point-slope form. So I know my answer is going to look like this, of the line that passes through the given point and has the given slope. So we go through this point and we have this slope. So this is my x1, y1, and that's my slope. So y minus y1 equals the slope times x minus x1. I'm not going to leave my final answer, y minus negative 3, because minus a negative 3 is really plus 3. So we have y plus 3 equals, oh, I did 2 over 2, that's 2/3. 2/3 times x minus 9. It asks for the equation in point-slope form, so I am finished. I do not need to convert this to slope-intercept form. Over here, again, my x1, y1, and my slope, y minus y1 equals the slope times x minus x1. But I'm not going to write minus a negative. I'll do y plus 17 equals negative 4 times x plus 8. And if you want to jump right to this equation with the plus, you can absolutely do that. I just wanted to show where that plus really came from. Down here, graph the equation. Well, when I look at this, I have to think, well, what form is this equation in? This right here is in point-slope form. I see y minus y1 equals the slope times x minus x1. If I want to convert it to slope-intercept form, because that's how I'm most comfortable graphing, I can distribute. So I'm going to do that over here. I'm going to show two different ways of doing this. If I distribute, I would have y minus 4 equals negative 3 halves x. Negative times a positive is a negative. 3 over 2 times 5 would be 15 over 2. Now when I add 4 to both sides, I get y equals negative 3 halves x. Negative 15 over 2, well, that's really a negative 7.5 plus 4. If I do 15 divided by 2. Now if I make that negative 7.5 plus 4, I see that I get a negative 3.5. So minus 3.5. So the y-intercept is a negative 3.5. Now because it's a decimal, I think that's a little messy. You could go ahead and graph it, y equals negative 3.5, and then rise a negative 3 and run 2. However, I'm going to consider this in point-slope form. If I just look at it in point-slope form, I can identify a point on the line and a slope. The point would be, well, opposite of negative 5 would be negative 5. Opposite of minus 4 would be positive 4. So I could go to the point negative 1, 2, 3, 4, 5, 1, 2, 3, 4 on the graph and plot that point. I know that has to be on the graph. I also have a slope of negative 3 halves, which means we're going to be decreasing. The slope is negative, so I'll be decreasing. So I'll go down 3, right 2, down 3, right 2, down 3, right 2. Now if I graph this line, I can see that I will have a y-intercept of negative 3.5, which follows that of the slope-intercept form, but I think it was easier, instead of dealing with the decimals for the y-intercept, to go with the point and the slope. But you could have gone about it this way. Over here, I look at this, I don't have y equals, so it's not in slope-intercept form, but it's also not in point-slope form. So if I'm not in either one of the forms already, I have to get it into one of the forms. And the easiest way to do that is to solve for y and get it into slope-intercept form. So I subtract 5x from both sides, and I'll have negative y equals positive 5x plus 2. But I need to get positive y, so I'm going to divide everything by negative 1, and I get y equals a negative 5x minus 2. Excuse me. So y-intercept of negative 2 and the slope of negative 5 means I go down 1, 2, 3, 4, 5, right 1, or I could go up 1, 2, 3, 4, 5, and left 1, and I would still get that slope. So here is okay. And then finally over here, when I look at this one, again, it's not in slope-intercept form because I don't have y equals by itself. It is in point-slope form, so I could do what I did for the first one and say, oh, well, that would be a positive 4, comma, positive 8 with a slope of 2. But when I go to graph that, I look 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. I'm kind of off the graph. So this time, let's go ahead and convert this to slope-intercept form because that's another tool we could use. I distribute and I get y minus 8 is equal to 2x minus 8. If I add 8 to both sides, I get y equals 2x. Well, a negative 8 plus 8 adds to be 0. So it's just y equals 2x. That means my slope is 2 and my y-intercept is 0, comma 0. You can imagine there's like an imaginary plus 0 there. So I plot my y-intercept of 0, 0. My slope is 2. You can make that 2 over 1 if you want. Rise 2, run 1, and so on. Or down 2, left 1. And then when I graph this, I can see that the point 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, yep, it would fall right on there. So that makes sense that this graph would have the point 4, comma 8 on it. All right, scooching down to number 4. It says write 2 equations in point-slope form. So here's 2 equations in point-slope form and 1 in slope-intercept form for this graph. All right, so let's start with slope-intercept form because I know that one the best because I've worked with it the most. That's what we've studied all through middle school. So slope-intercept form is y equals mx plus b. So I'm thinking in my head, well, what information do I need in order to write the equation in slope-intercept form? Well, I need the slope and the y-intercept. So let's go to this graph. The slope, I can go down 1, right 1, down 1, right 1, down 1, right 1. So the slope would be negative 1 over a positive 1, which just simplifies to negative 1. I could have also taken the 2 points that are shown and make a table, my x and my y, so that's negative 3 and 6, and then 4 and negative 1. Here I subtract 7. Here I add 7, so my slope would be negative 7 over 7, or negative 1. So another way to find the slope. For slope-intercept form, we need the slope and the y-intercept, so I go to the graph. Here is my y-intercept, 1, 2, 3, so the y-intercept is 0, comma 3. So my equation in slope-intercept form would be y equals negative x plus 3. You can put a negative 1 in front of x if you'd like, but I'm just going to leave it as negative x. So point-slope form. The reason I can have more than one equation in point-slope form is because in order to write the equation of the line in point-slope form, we look back here, we need a slope and a point on the line. Well, I'm thinking to myself, there's a lot of different points on that line, so I could write a lot of equations in point-slope form for this function. When I look in here, we have these 2 points that were given, so I'm just going to use those points. So we have y minus y1 equals the slope times x minus a negative 3 here will really make this plus 3. To use the second point, y minus a negative 1 would really be plus 1 equals the slope, which was negative 1, times x minus x1 is a positive 4, so we're going to subtract 4. And there you go. Now there's more than that. You can take any point on here. Here's the point negative 4, comma 7. Here's the point negative 1, comma 4. You could use any point you want. I just used the 2 that were on the graph. But there's an infinite number of equations you can write in point-slope form. There's only one you can write in slope-intercept form because in order to write the equation in slope-intercept form, you need the slope and the y-intercept. There's only one y-intercept and one slope, so that's it. That's the only option for slope-intercept form. Excuse me, scooching down here. It says, begin by writing an equation in point-slope form that passes through the 2 points, then convert the equation into slope-intercept form. Okay, well, I'm given 2 points. So I first need to find the slope. The slope will be equal to, we made a table over here, but I'm going to use the slope formula. y2 minus y1 over x2 minus x1. So this is really plus 16, so that'll be a positive 6 over a negative 2. The slope will be negative 3. So in point slope form, I can choose either one of these points. It doesn't matter. So one equation could be y, that's a negative 16, so I'll see plus 16 equals the slope times x, I'll choose this one, plus 2, the opposite sign. Or if I use that point, y plus 10 equals negative 3 times x plus 4. Now, it wants us to write it in slope-intercept form. Because it's only given us 2 points and not the y-intercept, I'm going to use one of these that is already in point-slope form to convert to slope-intercept form. All right, so I don't need to jump right to slope-intercept form. I start in point-slope form and then convert it to slope-intercept form. And you'll see that no matter which equation you use, you'll still get the same slope-intercept form. So I'm going to do the work on this piece of paper. If I started with y plus 16 equals negative 3 times x plus 2, I distribute and I see that y plus 16 equals negative 3x minus 6. Subtract 16 from both sides, and I get y equals negative 3x minus 22. Now, I want to try the other equation. The other point slope form we had was y plus 10 equals negative 3 times x plus 4. I can distribute here and get y plus 10 equals negative 3x minus 12, and I subtract 10 from both sides, and I get y equals a negative 3x minus 22. You see, it's the same slope-intercept form either way. Another way that students have done this problem is by making a table. So look in here, I had we had negative 4, negative 10. We didn't know what coordinate was with negative 3, but then I had negative 2, negative 16. We'll have negative 1 and something, 0, 1, 2, and so on. We saw that the slope was minus 3, or negative 3, so that means every time we add 1 for the x, we're going to subtract 3 from the y. So negative 10 minus 3 would be a negative 13. Subtract 3 again, I get to negative 16. Subtract 3 again, I get negative 19. Subtract 3 again, I get negative 22, negative 25, negative 28. And you'll see that where our y-intercept is, meaning where x is 0, we get negative 22. So you could use a table as well to reason through this. Either way, we'll get y equals negative 3x minus 22. Looking over here, it's still giving us 2 points, it's just the notation's a little different. This is the point 28, 15, because what's inside the parentheses is the input, or the x value, and what outside is the output, or the y value. 32, 20. I still first have to find the slope. So 20 minus 15 over 32 minus 28 gives me a slope of, what is that, 5 over 32 minus 28 would be 4. So there's my slope. If I write the equation point slope form again, I could use either one of these points. I could say that it's y minus 15 equals 5/4 times x minus 28. Or I could say y minus 20 equals 5/4 times x minus 32. Doesn't matter. Again, to get slope-intercept form, I'm not given the y-intercept. I have the slope, but I need to find the y-intercept. We can either do that by using one of these in point slope form and converting to slope-intercept form, or by making a table. So let's first start by writing these, converting the point slope form. So here, if I start with y minus 15 equals 5/4 times x minus 28, the first thing I have to do is